Hi, my name is Matt Foster, and I'm a sales executive at Uniweld Products. Uniweld is a U.S. manufacturer, and since 1949 has employed over 300 workers who help design, manufacture, and distribute U.S.-made products to be sold worldwide. Uniweld's world headquarters and manufacturing facility, based in Fort Lauderdale, Florida, has state-of-the-art robotic CNC machines that produce quality flame tools, accessories, and pressure gauges for the air conditioning, refrigeration, plumbing, heating, automotive, and maintenance industries. Today, we will focus on flame tools, the proper safety guidelines to follow when using flame tools, and helpful tips and techniques for brazing applications. Now, the most common oxy-fuel processes are cutting, heating, welding, and brazing. The safety principles we will discuss apply to each of these processes. Starting with the foundation of combustion, it's important to understand the fire triangle. Combustion requires three elements: fuel, oxygen, and an ignition source. If one of these three things is removed from the triangle, a fire can't exist. Now, we will refer back to the fire triangle as we talk about how to safely use a torch. Now, before using any flame tool, make sure your work area has adequate ventilation and the surroundings are free from combustible materials. This includes oily rags, paper, flammable liquids, and anything else that could potentially catch fire. These items need to be removed from the area. Eye protection is also very important to protect against any flying debris and the small amount of infrared rays produced by an oxy-fuel flame. Use whichever eye protection is most comfortable for you: a tinted face shield, goggles, or safety glasses. Always have a fire extinguisher nearby in case of an emergency. The most widely used fuel gases in the HVAC industry include propane, propylene, acetylene and air, and oxyacetylene. Propane has a target heat of 1700 degrees. Propylene has a target heat of 2400 degrees. Acetylene and air has a target heat of 2700 degrees, and acetylene and oxygen, also known as oxyacetylene, has a target heat of 5600 degrees. As you can see, there is a big difference in temperature when oxygen is added to the acetylene fuel. Always identify the contents of a tank by the label, never by the color of the tank, as tank colors may vary. Never use a tank that is low on pressure or near empty. All tanks should be stored upright and secured to prevent a tank from tipping over. Propane and propylene come in small, disposable bottles that are not refillable. These bottles are very portable and great for soldering. A self-igniting hand torch like Uniweld's HT44 will screw onto the bottle and give you instant controlled heat in the palm of your hand. This is the Uniweld HT44 Twister 2 self-igniting hand torch. It works with both propane and MAP Pro brand propylene and connects to the cylinder here at the bottom. The brass thread insert prevents galling and cross-threading when connecting directly to the cylinder. Many other hand torches are made with a cast aluminum body, which means the threads are aluminum as well. They'll deteriorate over time from connecting and disconnecting from the fuel cylinder. The HT44 has a nice full-size ergonomic grip. It's very comfortable to hold and maneuver the torch. The valve here on the back controls the flow of gas, and there's an internal filter that protects the fuel injector from clogging. To light the torch, we'll simply open the valve on the back and pull the trigger for ignition. Hold the trigger down and adjust the valve for the desired size flame. Take note that if the valve is not open enough, it is possible to starve the tip, which will draw the flame back and have it burning inside the tip. This can cause the tip to become red hot and can potentially burn the igniter, so make sure the valve is sufficiently open. The HT44 can operate in any position, even upside down, to help reach those really tight workspaces. And the tip can rotate 360 degrees by simply loosening the black plastic nut and retightening when the tip is in the desired position. The twister tip has a helical blade inside that creates a swirl combustion and increases fuel velocity. This also makes the flame more stable in windy conditions. Release the trigger to turn it off, or use the trigger lock for a constant flame without holding the trigger. Squeeze the trigger to release the trigger lock and turn off the torch. When you're finished with the job, simply close the valve, disconnect the hand torch from the cylinder, and engage the safety trigger lock for safe storage. Let's review. The fire triangle consists of three elements: fuel, oxygen, and an ignition source. Make sure the workspace is well ventilated and clear of combustible materials. Always wear eye protection when using flame tools. And always have a fire extinguisher nearby. Always identify a tank by its label. Store tanks upright and secured. Never use a tank that is low on pressure or near empty. Acetylene tanks are refillable and will come in either a large B tank or a smaller MC tank, designed for portability. Now, a little history lesson about acetylene. The letters B and MC, which refer to the tank sizes, stand for bus and motor car. Acetylene tanks used to be installed on vehicles to light the headlamps. MC referred to the smaller size tank for a car, and B was the larger tank for a bus. It is important to know that acetylene tanks are very different from other tanks. The inside is filled with a porous core that is saturated with liquid acetone. And during the filling process, acetylene gas is pumped into the tank and absorbed into the liquid acetone. And as you use the gas, it is released from the acetone, much like carbonation is released from soda when you open a soda bottle. The tank is designed this way to help with the filling process and to stabilize the very volatile acetylene gas. Acetylene tanks should always be stored in an upright position so that the acetone will settle at the bottom of the tank. If a tank is stored on its side, the acetone can make its way up the tank towards the valve. Now, if you try to use this tank with a torch, it is possible to draw liquid acetone out of the tank and cause a very serious fire hazard. If an acetylene tank has been stored on its side, allow it to sit in an upright position for 45 minutes to an hour to allow the acetone to resettle in the bottom of the tank before use. Acetylene has a tendency to disassociate above 15 psi, which can cause a chemical reaction. Acetylene should never be used above 15 psi, which is why you will see a red line at 15 psi on all acetylene regulators. Oxyacetylene is the most commonly used fuel for brazing in HVAC applications, and as we saw before, there is a big difference in temperature when oxygen is combined with the acetylene. Oxygen by itself is not flammable, but it will greatly increase the flammability of any fuel source, which includes items in your vicinity or even your clothing. Do not use oxygen to blow dust off of your work area or clothing. Oxygen should never be used in the place of compressed air. Oxygen comes in many containers. For HVAC and refrigeration applications, it typically comes in a refillable, large 40 cubic foot R40 tank or a smaller 20 cubic foot R tank designed for portability. Oxygen tanks are filled to a very high pressure, around 2200 psi. Pure oxygen can lower the kindling temperature of petroleum-based lubricants to room temperature. With some friction, this can cause a violent explosion. Never apply oil, solvent, or any lubricant to an oxygen tank, tank valve, oxygen regulator, or any component of an oxy-fuel system. Let's review. Acetylene tanks have an acetone-saturated core and must be stored upright for the acetone to settle in the bottom of the tank. If an acetylene tank has been on its side, allow it to stand upright for 45 minutes before use. Never use oxygen to blow dust off the work area or clothing. Oxygen should never be used in the place of compressed air. Never apply oil, solvent, or any lubricant to an oxygen tank, tank valve, regulator, or any component of a torch system. Your first safety check is to ensure all valves, threads, and seats are free of oil and dirt. Inspect the fittings on the tanks and regulators to ensure they are not damaged in any way. Before connecting the regulators, direct the tank valve away from you and anyone else nearby, and briefly open and close the valve. This will clear the valve assembly of any combustibles and contaminants. Do the same for the fuel gas tank. Now we are ready to attach the regulators. The seat for these connections is metal to metal and needs to be tightened with a wrench. Next, inspect your hoses. The red hose will attach to the acetylene regulator, and the green hose will attach to the oxygen regulator. Notice that the nut on the red acetylene hose has grooves to indicate a left-hand thread. The nut on the green oxygen hose does not have these grooves, indicating a right-hand thread. If you see any oil or grease present, or you see cracks in the hose, do not use it. Change the hose. Now attach the hoses to the regulators using a wrench to secure the connections. The hoses need to be purged to remove any potential contaminants that may have entered the hose during manufacturing or storage. If not removed, this contamination can cause clogging of the equipment or a source of combustion. Let's start with purging the oxygen hose. Make sure the pressure adjusting screw is backed out counterclockwise all the way. Position the tank so the valve is between you and the regulator. Slowly crack open the valve, and once the gauge stabilizes, open it all the way. Do the same for the acetylene tank, but only open the valve 1/2 to 3/4 of a turn. The reason for this is in case of an emergency situation, the fastest way to extinguish the torch is to remove the fuel from the fire triangle by closing the tank valve. Use the included chain to tether the tank key to the regulator so it never gets lost. A tank key or a ratchet wrench should always be installed on the acetylene tank valve so that it can be shut off quickly. Now, to purge the hose, turn in the adjusting screw to 5 psi and allow it to flow for a few seconds. The amount of time to purge the hose will vary depending on the length of hose. Back out the adjusting screw once the hose has been purged and repeat the process for the other hose. Before we continue, let's go over some of the hazards associated with oxy-fuel equipment and how to prevent them. Reverse flow is when either the oxygen enters the fuel gas side of the system or the fuel gas enters the oxygen side of the system. This occurs when there is a restriction of one of the gases or an imbalance of pressure. This can be caused by a clogged or blocked tip or allowing one of your cylinders to run out of gas. Check valves are designed to stop the gas from entering the wrong side of the torch. If a reverse flow exists, a flashback can occur. Flashback is the return of a flame through the torch, into the hose, and even into the regulator. It could potentially reach the cylinder. This condition could cause an explosion anywhere within the system. Flashback arresters are designed to prevent the flame from traveling beyond the point of the arrestor. Flashback arresters contain a sintered filter, which prevents a flame from passing through the filter element. A backfire is the return of the flame back into the torch, which produces a popping sound. The flame will either extinguish or reignite at the tip. This is normally the result of accidentally bumping the tip against the workpiece or allowing the tip to become overheated. A sustained backfire is when a backfire occurs and continues burning in the torch. This condition may be accompanied by a popping sound, followed by a continuous hissing sound. Some of the causes of this are improperly maintained equipment, overheating the equipment, or improper pressure setting for the equipment being used. Some welding handles have built-in flashback arresters and check valves. If it does not, we strongly recommend installing them. Built-in flashback arresters are not recommended because they cannot be replaced if damaged. A good rule of thumb is to install them as close to operation as possible, which is between the hose and the handle. Now that everything is connected, before we use the equipment, we must first perform a leak check of all of our connections. First, back out the adjusting screw all the way. Open the gas slowly until the high pressure gauge stabilizes. Then shut off the cylinder valve and monitor the gauge for any pressure drop, which would indicate a leak at the tank connection or the high pressure gauge connection to the regulator. If no leak is evident, open the cylinder valve and adjust the oxygen regulator to deliver 20 psi. Open the acetylene cylinder valve and adjust the acetylene regulator to deliver only 10 psi. Close both the oxygen and fuel cylinder valves. Turn the adjusting screw counterclockwise 1/2 turn. Observe the gauges on both regulators for a few minutes. Open the cylinder valves again. Any movement of the needles would indicate a leak either at the hose connection to the regulator or handle, or a leak at the delivery gauge connection to the regulator. If you observe a leak, check all of the connections to identify the leak location. Soapy water can be applied to each connection to help locate the leak. If you cannot find the leak, have your equipment inspected by a qualified technician. Let's review. Use a wrench to secure all metal-to-metal connections. After all connections of an oxy-fuel system are secured, perform a leak check before using the torch. A tank key or a ratchet wrench should always be installed on the acetylene tank valve so that it can be shut off quickly in an emergency. Use flashback arresters with check valves to prevent reverse flow and flashbacks from occurring. Reverse flow is when either the oxygen enters the fuel gas side of the system or the fuel gas enters the oxygen side of the system. Flashback is the return of a flame through the torch into the hose and into the regulator. Backfire is the return of the flame back into the torch, which produces a popping sound. This is normally the result of accidentally bumping the tip against the workpiece or allowing the tip to become overheated. A sustained backfire is when a backfire occurs and continues burning in the torch. This can be caused by improperly maintained equipment, overheating the equipment, or improper pressure settings for the equipment being used. Next, we will select a tip. For a detailed explanation on tip selection, I'd like to turn it over to a younger version of me. Matt, take it away. Proper tip selection is an important step when brazing copper tubing during the installation of an AC or refrigeration system. But how do I know what size tip to use? Well, the size of the job determines the size of the tip, and the size of the tip determines the pressures to set on your regulators. Now, if you're using a tip that's too small for the job, you won't be able to bring your copper tubing up to the target temperature needed. If you're using a tip that's too large for the job and you compensate by dialing back your fuel pressure, you will starve the tip. This means there will not be enough pressure to push the flame out and have it burning outside the tip. It will actually draw back inside and be burning inside the tip. This will cause your tip and handle to become very hot and can lead to equipment failure. To find the proper tip size for a job, reference Uniweld's HVAC catalog tip chart. This shows you all of the available tips Uniweld has to offer, along with regulator settings and tubing capacity for each tip. Typical HVAC line sets will be 3/8 or 7/8, so let's say you'll be working on a 7/8 piece of copper tubing. Scanning the copper tubing sizes on the chart, you see a tip with a 1-inch capacity. This is very close to 7/8 and will work best for this job. The chart tells you to use a Type 17-2 tip, and the regulator pressure should be set at 5 psi for oxygen and 5 psi for acetylene. Now that you have selected the proper tip, the 2 O-rings on the mixer should be inspected to ensure that they are still intact. Now, if these O-rings need to be replaced, they're available at your local HVAC distributor under part number TXRK. And this kit comes with 10 O-rings, 5 of each size, and you simply slide off the old O-rings and slide the new ones on. We'll be working on a 7/8 inch tube, therefore we will use a Type 17-2 brazing tip. Inspect the tip before connecting it to the handle. Ensure the mixer is clear of any debris or contaminants and that there are 2 O-rings present and they are free from any damage. Because this is an O-ring seal, connect the tip to the handle hand tight only. Over-tightening of the tip can crush the O-rings and cause a hazardous leak or improper mixing of the fuel and oxygen. Now, before we open up the tanks, we must make sure the pressure adjust screws are backed all the way out. If they're left screwed in and the tanks are opened, this sudden burst of pressure can damage the diaphragm inside the regulator. Uniweld's oxygen regulators all have a built-in spring-loaded pressure relief valve that will vent this overpressure and save the diaphragm from damage. But it is still good practice to back out the adjusting screws every time before opening the tanks. To find the correct delivery pressures, open both handle valves. Then dial in the acetylene pressure adjusting screw to 5 psi and light the torch. The only approved tool for lighting a torch is a flint striker. Never use a lighter or any open flame to light a torch. Now continue to dial in the pressure adjusting screw until you have a clean burning soot-free flame. Next, dial in the oxygen pressure adjusting screw until you achieve a neutral flame. Now that the pressures are set correctly, close the oxygen handle valve first, then close the acetylene handle valve. Take note of the delivery pressures on both regulators. These are the correct pressures to dial in every time you use this size tip. If the tip is changed to a different size that requires different pressure settings, follow this procedure again to find the proper pressure settings for that tip. Now the torch is ready to be used. Open the acetylene handle valve and using a striker, light the tip. Adjust the valve at the handle to have a clean burning flame. Continue opening it until the flame is free of soot. Then introduce the oxygen and adjust the valve to get the desired flame. Never pre-mix the acetylene and oxygen when lighting the torch. This can cause a backfire or reverse flow and will damage your equipment if this is done repeatedly. Always light the acetylene first, then add the oxygen. There are 3 different flames that can be achieved depending on the ratio of acetylene to oxygen. A neutral flame is an even 1-to-1 mix of acetylene and oxygen. When there is more acetylene in the mix, it is called a carburizing flame. And when there is more oxygen, it is called an oxidizing flame. Typically, when brazing copper, a carburizing flame will produce the best results. To get a carburizing flame, open the oxygen valve until the white feathers disappear into a broad blue cone. This flame will heat the copper evenly and give a good wraparound to the back of the tubing. To shut down the torch, turn off the oxygen valve first, then turn off the acetylene. If the acetylene valve is closed first, it can cause a backfire or flashback. This can damage your equipment, so be sure to shut off the oxygen first, then shut off the acetylene. To fully shut down the torch, close both tank valves. Release the acetylene pressure at the handle valve until the gauge reads 0 and close the valve. Release the oxygen pressure the same way. Leave the pressure adjusting screws dialed in when the torch is not in use. This will leave the internal seat suspended and prevent the rubber seal from deforming. But you must remember to back out the pressure adjust screws before opening the tanks next time you use the torch. Wrap the hose around the hose holder and store the torch kit securely to avoid tipping over. Let's review. Use the proper size tip for the size of tubing being worked on. Before connecting a tip, make sure the mixer is clear of debris and 2 O-rings are present and in good condition. Hand tighten the tip to the handle. Do not over-tighten the tip. Back out the pressure adjusting screws on the regulators all the way before opening the tanks. Always light the acetylene first and open the handle valve until you have a yellow soot-free flame. Then introduce the oxygen. Never pre-mix the acetylene and oxygen when lighting the torch. To turn off the torch, close the oxygen handle valve first, then close the acetylene handle valve. To shut down the torch, close both cylinder valves, then release the acetylene pressure at the handle valve until the gauges read 0. Then do the same for the oxygen. The brazing process consists of the broad heating of the base metals to the point where the filler metal applied to the joint will be melted and drawn by capillary action through the entire joint. After cooling, the brazed joint will have a strong bond between the filler metal and the 2 base metals. Flux is a chemical compound, usually made in the form of a liquid or paste, which is applied to the joint surface prior to brazing. Its purpose is to protect the joint surface from the oxides that form during heating. Flux melts and becomes active during brazing, absorbing oxides and assisting in the flow of the brazing alloy. Fluxing is generally an important part of the brazing process, but it plays only a minor role in brazing HVAC and refrigeration components because most of these joints will be copper to copper. When brazing copper to copper, you can eliminate the flux by using a phosphorus-bearing filler metal because the phosphorus acts as a fluxing agent. As a filler metal, you will use a silver alloy. The silver content helps the filler metal flow better when melted and will allow the cooled joint to be flexible and absorb the harmonic vibrations that run through a system when the compressor is running. Without the silver in the filler metal, the joint would be too brittle and would crack from the vibrations. The more silver contained in the alloy means the joint will be more flexible. It is recommended to use a 15% silver phosphorus brazing rod when joining copper to copper in an HVAC or refrigeration system. Capillary action, the basis of all brazing, can't work properly on dirty surfaces. If the surfaces of the metals are contaminated with oils or dirt, the brazing filler metals will not adhere to them and the joint will fail. Oil and grease can be removed with a solvent, and oxides can be removed by an abrasive like an emery cloth or wire brush. Once the parts are cleaned, it is recommended to braze as soon as possible so the parts won't have time to become recontaminated. The actual brazing operation is a two-part process. First, heating the base metals, and second, applying the filler metal to the joint. Be sure to heat both base metals broadly and evenly so the filler metal will wet equally well on both metal surfaces and completely fill the joint. Start heating the tube about 1 inch away from the end of the fitting. Then shift the heat to the fitting. Sweep the heat steadily back and forth from tube to fitting, with most of the heat being applied to the heavier and slower to heat fitting. Heat the assembly until it reaches brazing temperature. You can tell it's up to temperature by the dull red color of the metals being heated. At this point, pull the flame back a little and apply the filler metal firmly against the tube and the junction of the tube and fitting. If the joint has been properly heated, the filler metal will melt, penetrate, and completely fill the joint. The filler metal will always flow towards the heat, so direct the flame behind the joint to draw the filler metal inside. Allow the braze joint to cool naturally for a secure, strong bond. Another very important step when brazing refrigeration and HVAC systems is to run nitrogen through the copper tube while brazing. For a detailed explanation on brazing with nitrogen, here's Matt again. This is Uniweld's NitroView nitrogen flow indicator, and this is nitrogen purging simplified. The NitroView easily connects in line with any nitrogen regulator and was designed to be protected from impact in case the tank tips over. The precision adjustable valve gives complete control over the flow of nitrogen, and the bright orange float ball provides a visual indication that nitrogen is actually flowing. The easy-to-read flow indicator label has 2 zones clearly marked for purging and brazing, and there's a safety blow-off valve that will open at 200 psi to prevent overpressurizing. Now I'm going to show you how to braze a copper fitting together with nitrogen flowing through the line to prevent oxidation and the resulting scale. So I have 2 pieces of copper tubing set up here. My top tube is open at both ends and exposed to the ambient air, and the bottom tube at one end is open, the other end is closed with an access fitting brazed into it. And attached to that access fitting I have the nitrogen tank. So we're going to braze 2 pairs of copper fittings together, one on the top tube and one on the bottom tube with the nitrogen flowing through it, and we'll take a look at the difference. First, I'll dial in the delivery pressure on the regulator to 60 psi. This is the required pressure for the NitroView to work properly. Then I will open the valve and raise the ball up to the purge zone and allow the air present in the tubing to be pushed out. Now if your flow ball does not rise, this means that there's static pressure and the nitrogen isn't able to flow. So you have to make sure that your system is open at both access points so the nitrogen can flow freely. After 10 to 15 seconds of purging, I can bring the float ball back down to the braze zone. Now in this zone, the nitrogen will be flowing at 3 to 5 SCFH. It's important to have this low flow of nitrogen because if there's too much flow, the nitrogen will actually push back on your joint. It's going to cause pinholes in your alloy. It's not going to give you a very good seal on your joint. So it's important to have your NitroView set in the braze zone to give you that low flow of nitrogen. By flowing the nitrogen through the tubing during brazing, oxidation will be prevented. Oxidation is the chemical reaction that occurs between copper and oxygen when heat is applied. Now this chemical reaction forms a layer of black flaky scale on the tubing called copper oxide. So all the scale that you see on the outside of the tubing after brazing a joint is actually also happening on the inside. And it's important to prevent the scale buildup inside the tubing because when it combines with the refrigerant, it will form a sludge that can clog the TXV valve and other components, leading to system failure. By flowing nitrogen through the line during the brazing process, the oxygen is displaced inside the tubing and the copper oxide will not form. Now I'm just going to cool these two joints with a wet rag and wipe off the scale that formed on the outside of the tubing so that when I do the tap test, we will only see what falls out of the inside of the fittings. Now as I tap the fittings on this white table, you can see the black scale falling out of the joint brazed without the nitrogen. The joint that was brazed with nitrogen flowing through it has no scale to fall out and is perfectly clean on the inside. I'll just cut these joints open to get a better look on the inside. Uniweld's NV1 Nitro View is truly nitrogen purging simplified. Now let's talk about some other Uniweld tools that will help with the brazing process. Over the years, the HVAC industry has seen various methods of connecting copper tubing. And as new products for connecting tubing have come out, like epoxies, flare connections, and O-ring crimp fittings, one method has truly stood the test of time. Brazing copper lines is the most reliable, time-tested, and proven procedure for a leak-free connection in the HVAC and refrigeration industry. When you braze your copper lines, you have confidence in your work, and you know that system is going to run reliably for years to come. Now in certain situations like this here where you're working in a tight space and inside of a wall, it may seem difficult to use a torch to braze this copper tube. But with safety as a priority, Uniweld offers several tools to help make strong and reliable brazed tubing connections while also reducing the cost of the job. Now with the continuously increasing price of copper, one of the best ways to reduce costs is to eliminate copper fittings. Uniweld's UEK1 hydraulic expander tool has a compact 90-degree design to allow it to fit in this small space and swage the copper tubing with ease. The expander is only to be used on soft copper. If the tubing is hard-drawn copper, it can be annealed with a torch first, and then it can be swaged. By swaging the tubing, I have just eliminated the need for a copper coupler, and now there is only one joint to braze instead of two, which lowers the chances of a leak, cuts the brazing time in half, and reduces the amount of silver alloy that will be consumed. Now I need this copper line to turn 90 degrees and extend out past the drywall. I'm going to use Uniweld's RTB 118 ratchet tube bender to make a 90-degree bend. This tool is intended for use with soft copper or aluminum, and it can create precise bends up to 90 degrees with minimum distortion for optimal flow. It is helpful to lubricate the mandrel so the tubing can flex easily as it is being reshaped. Repeatedly squeeze the handle until the desired bend is achieved, then simply push the handle down to release. The ratchet tube bender just eliminated the need to buy a 90-degree elbow, which lowers the cost of the job again and reduces the number of joints to braze. Now that our tubing is swaged and our bend is ready, let's prepare to braze. Remember, when using flame tools, it's important to always follow proper safety procedures and have a fire extinguisher nearby. For eye protection, Shade 5 goggles are great for welding and cutting steel, but are a little dark for brazing. Uniweld recommends Shade 3 goggles. They protect your eyes and still allow you to see your work. Now when brazing in small spaces, it's important to protect the surrounding area from the intense heat of an oxyacetylene torch. Uniweld's FB12 flame barrier is a great solution for this. The flame barrier can withstand up to 3,200 degrees of direct heat. It can take the direct flame from a MAP Pro or propane hand torch, an air acetylene torch, and the secondary flame of an oxyacetylene torch. But if you leave the oxyacetylene flame on too long, it will burn through it. The flame barrier is flexible, and it can be cut so that it can perfectly fit the workspace and protect the drywall, exposed wiring, and any other nearby sensitive materials. Since this braze is inside a wall, position the flame barrier to prevent the flame and heat from going up into the interior wall and possibly catching the house on fire. If necessary, use thumbtacks or small nails to hold the flame barrier securely in place. Now let's braze this joint using a Uniweld torch. Another great tool for brazing in a small space is the MTF5 cap and hook tip. that features 5 flames for 100% wraparound on the tubing. There is no heat on the back of the tip, and the 45-degree flame angle directs the heat down the tubing and away from any nearby sensitive materials. The pipe will heat evenly and quickly, reducing the time spent with the flame in the wall. As the tubing heats up and becomes red, feather the flame off and on the tubing to control the heat and prevent melting the copper. The capillary action of the alloy and the even heat distribution on the tubing causes the alloy to flow around the joint completely. The alloy will always flow towards the heat, so move the flame slightly behind the joint to draw the alloy inside for a solid, leak-free connection. After brazing is complete, the flame barrier can be folded and kept in a dry place for future use. When using the proper tools from Uniweld, like the UEK1 hydraulic expander, the RTB118 ratchet tube bender, the FB12 flame barrier, and the MTF5 cap and hook tip, brazing in tight spaces is a simple task, and you'll see more profits on your bottom line by reducing your costs. Now let's talk about how to solder aluminum using Uniweld's Uni 4300 soft solder kit. Hi, Matt here with Uniweld Products. For a combination of reasons such as cost and higher efficiencies, more manufacturers are now building their evaporator and condenser coils using aluminum. Now, as more of these aluminum coils are introduced to the market, technicians will be faced with the challenge of making aluminum repairs. Now, working with aluminum is a little different than working with copper because soldering aluminum is a low temperature process and potentially it can cause more problems if executed poorly. Now, regardless of what soldering or brazing apparatus you're using, it's all about controlling the heat. So whether you have a pitted coil or a leak at a transitional joint, or maybe somebody accidentally drove a screw through the coil while they were putting the panels back on, you'll be prepared with Uniweld's Uni 4300 soft solder kit. Now, the Uni 4300 kit can be used to join aluminum as well as dissimilar metals like aluminum to copper, aluminum to brass, and copper to brass. And it's the best option for aluminum coil repair because it has a very low melting point of 500 degrees Fahrenheit and a high tensile strength of 20,000 pounds. Now, the kit comes with a 10-foot coil of soft solder, a 2-ounce bottle of flux, and a convenient flux applicator with a metal tip. Now, the flux applicator allows you to reach really tight spots, and that metal tip allows you to apply flux to a preheated tubing without melting the tip. Now, I have an aluminum evaporator coil here, and I've identified a hole just behind the fins. So using Uniweld's Uni 4300 kit, let's go ahead and repair this hole. The fins have been removed. Now, for the best results, remove any oil and grease from the surface using a chemical solvent and remove any oxides using a stainless steel wire brush or emery cloth. The tubing has been cleaned, so let's now prep our flux. Pull the plunger out of the syringe and squirt the flux into the barrel. When you have enough flux for the job, insert the plunger into the barrel, point the metal tip up, and squeeze out any air. Now, before applying the flux, preheat the tubing. This will help prevent the flux from burning and becoming an inhibitor that prevents the alloy from bonding properly to the base metal. Using the flux applicator, apply flux to the area where the bond will happen. Continue heating the tubing by feathering the flame on the sides of the bond area and allowing the heat to transfer in toward the flux. As the flux heats up, it will begin to bubble, and you'll notice a little flash of green. At this point, the solder can be applied. Don't use the flame to melt the solder. Instead, the base metal should be hot enough to melt the solder on contact. Now, it is possible to overheat the flux and burn it. If this happens, the flux will turn brown and the solder won't flow right away. But that's okay. Just add a bit more flux and a little more heat, and you'll see that solder smooth right out. Allow the aluminum to cool and clean the area of any residual flux. Save any remaining flux in the syringe by squeezing it back into the flux bottle, and clean the syringe by squeezing some water through it a few times for future use. Uniweld's Uni 4300 soft solder kit makes aluminum coil repair a quick and simple task, and the same process should be used when joining dissimilar metals as well. I hope you've learned something today and that this information will help keep you safe on the job site. Remember, safety is your responsibility. Always be aware of your surroundings and equipment. Thanks for watching. I'm Matt with Uniweld, quality tools that go to work with you.